Today's lesson is about how to apply the remainder and factor theorem. So we haven't really learned what the factor theorem is yet, but last time we learned what the remainder theorem was. That was when we had to use the synthetic and long division, and we found the remainder when we were dividing the polynomials. But today's essential question is, how can I use a known factor or zero to find the remaining ones? So first, the factor theorem tells us that if a polynomial has a factor x minus k, then whatever k equals is a zero of that polynomial function. So just to review, so you guys know what I'm talking about, if I have a graph, and I'm just going to just draw a picture of something, whatever it looks like, the points where the graph crosses through the x-axis are called our zeros of the function, because that is where y is equal to 0, or the function equals 0. So this particular one that I drew would have 4 zeros, which would mean that it has 4 factors if we were to factor all of the function down. So if we have a factor x minus k in that form, then whatever k equals would be a 0 of the function, because if I set x minus k equal to 0, whatever k equals will be the answer, the solution. So what are the uses of the factor theorem? Let's say that we know one of the factors and they want us to find the other factors. That would be one way to use it. Another way would be that if we're given a 0, like they already told us what the 0 is, then we can find the other zeros. Now remember, when something is in the form x minus k, we can use the synthetic division. So for all of these problems, we won't be using long division, we'll be using synthetic division. So here's the first example. Factor f of x equals 3x cubed minus 4x squared minus 28x minus 16 completely, given that x plus 2 is a factor. So what we're going to do is we're going to factor this polynomial. Now if I was going to try to factor this just right now, I would only be able to factor it by grouping, but this particular example does not work factoring by grouping. So I need to know one of the factors to be able to start this problem. So since I know that x plus 2 is one of the factors, and remember factors are the things we multiply to make up this answer, then that means if I take this part divided by x plus 2, then I know, then I can find out what the other factors are. So if x plus 2 is a factor, then I have to put the number that goes on the outside for synthetic division is the 0, not the factor. So if x plus 2 is the factor, if I set that equal to 0, then I would subtract 2 from both sides, so x would equal negative 2. So whatever x equals, that's what we put on the outside of our synthetic division. So if x plus 2 is a factor, what's the 0? The 0 would be negative 2. So I'm going to set up my synthetic division, and I checked to make sure that nothing was skipped. So I have x cubed, x squared, x, and then the constant. So this would be x cubed, x squared, x, and then the constant. So you put all the coefficients here. We start by bringing down the 3, and then we multiply these. So 3 times negative 2 would be negative 6. Then we add, so we get negative 10. Then we multiply, so we get positive 20. Then we add, so we get negative 8. Then we multiply and we get positive 16, and then we add and we get 0. Now remember, this is supposed to be your remainder, but if x plus 2 is one of the factors, it should divide in evenly, because it should be divisible by this if it's a factor, because I mean I can multiply this by something to get this answer. So if you don't get 0 as your remainder, then you made a mistake. So you'll need to go back and check your work. Maybe you forgot to put a 0 in as a placeholder, or maybe you just did your mental math wrong. So make sure you always get 0 as a remainder when you're dividing when you have a factor. So what does this part mean? Well, that would be what I get after I divide this out. So I would use the result to write the other factors in this, and then I'm going to factor it completely. So I'm going to extend this a little bit. This means, remember, this is the constant, this is the one that has the x, and this is the one that has the x squared. You just count forwards. So this would mean that I would take x plus 2 times 3x squared minus 10x minus 8, and that would give me what I started with. Well, I need to see if this is factored completely. So is this part factored completely? Well, let's see if I could factor that. Now this one has a number in front of the x squared. So if there's a number in front of the x squared, how do we have to factor it? We have to use a particular method called the AC method. So remember, this is A, B, and C. So we take A times C, which would be negative 24. And I have to find factors of negative 24 that add to be negative 10. So I could do 1 and 24, 2 and 12. So 2 and 12 might work. How would I get 2 and 12 to equal negative 10 and multiply to be negative 24? Well, the negative 12, or the 12 would have to be negative, and the 2 would have to be positive. So those are my factors. Now, when we're doing the AC method, remember, you have to rewrite this polynomial. So I'm going to rewrite it as 3x squared, and then I'm replacing the negative 10 with my factors that I found. So minus 12x plus 2x, and then minus 8. And so from here, what I can do is factor by grouping. So I'm going to group these, because now I have 4 parts. So the greatest common factor of the first part would be 3x. And then I would have left over x minus 4. And then I could take out a 2 here, positive 2, and I would have left over x minus 4. So what I would end up with, I could take out x minus 4, and then I would have left over 3x plus 2. And then originally I had x plus 2 in the front, so this would be the answer factored completely. So I started with this big function right here, and I couldn't do factoring by grouping, but I knew that x plus 2 was one of my factors, so I divided it by x plus 2, and I got this left over. And then I had to factor that using the AC method to get my other factor. So this would be the factored version of what we started with. So if I were to multiply these 3 things together, I would get what I started with. Okay, now let's see the other example that we're talking about. It says 1 0 of the function x cubed minus 2x squared minus 23x plus 60 is x equals 3. What are the other zeros of the function? So they're telling us the 0 this time. That's the key word. You have to tell if something is a 0 or if it's a factor. If it's a factor, then that's what you would actually take to multiply together, and that's usually written in parentheses. If it's a 0, they already tell you this is the point where it would cross through the x-axis on the graph. So if I was to draw you a picture of this, okay, let's say that this was my function. I'm just making this part up. Let's say my function was like this, okay? It tells me 1 0 is x equals 3, so that means it crosses through at 3. And then I have to see if there's any other ones, okay? So since they gave me the 0, that's what I plug into my synthetic division. I don't have to do any other work this time. So when I set up my synthetic division, I'm going to put 3 on the outside because that was the 0. So the 0 always goes on the outside. Then I bring down the 1. And feel free to pause the video and try this by yourself first. Then I multiply, and I get 3. And then I add, and I get 1. And then I multiply, and I get 3. And I add, and I get negative 20. Then I multiply, and I get negative 60. And I add, and I get a remainder of 0. Now that is what is supposed to happen, because it should be divisible by this. If it's a 0, there should be nothing left over. So now I have to rewrite my answer. Let's see if I can get this glue away. Okay, so we're going to use the result to write out the other factors. Now, this gives me x squared plus x minus 20. So remember, this is the constant, this is the one with the x, and this is the one with the x squared. So this was one of my factors, and if my 0 is a 3, then what factor goes with that? Well, remember, that's the answer when I set the problem equal to 0. So then my factor would have to be the opposite of that, which would be x minus 3. Because if I set x minus 3 equal to 0, then I get x equals 3. So that's why I used x minus 3 as my factor. So the factor and the 0 are always opposite of each other. So this would be the factored form. Okay, so I need to factor this part. So can I factor x squared plus x minus 20? Sure. I just have to find factors of negative 20 that add to equal 1. So I could do 1 and 20. That wouldn't work. 2 and 10. That wouldn't work. 4 and 5. And how could I make this equal 1? Well, the 4 would have to be negative. So my factors would be x minus 3, what I started with originally. I would have x minus 4 and x plus 5. Because if I take x minus 4 times x plus 5, I get this part right here. Now, it says, what are the other zeros? So now I have all the factors, but I want the zeros. So to get the zeros, you have to set all of these equal to 0. Now we already know that this one is going to come out to be 3 because that's the one we started with. Okay, so if I set this one equal to 0, then I would add 4 to both sides. And so I would get x equals 4. And if I set this one equal to 0, then I subtract 5 from both sides. So I get x equals negative 5. So my zeros are going to be 3, 4, and negative 5. So that means the graph is going to look something like this. Okay, it's going to cross through at 3. It's going to cross through at 4. 1, 2, 3, 4. So it's going to cross through at 3, cross through at 4, and it's going to cross through at negative 5. And we know since it's a cubic function that it's going to go something like this. Whoops, I kind of did that backwards. Hold on. So it should go something like this. So it would look something like that because it's going to make like a snake. It's going to go up on the right and down on the left because we know the end behavior would look like that. And then if it crosses through all of these points, it would have to look like that. So you guys just need to go back and answer your essential question and write your summary.